Alrighty. So, what is work? Something we all can't stand doing, right? Well, I'm gonna be honest with you. I can honestly say that I have been teaching for 20 years, close to 20 years, and I love my job. So I'm not fussing there. I just can't figure out what I will need to do up here because I'm talking and chewing gum at the same time. There we go. Um, but there's another kind of work, and that's the actual physical work, physics work. And I'm fixing to do this, and I'm fixing to move on. So I have to do this now because somebody comes in here and just totally messes up stuff. Of course, I don't. But and we're still waiting on the training. Haven't got training yet on these things. Huh? Yeah, they'll replace these projectors and they'll have training on these projectors while they train on the other ones. But this is right now. Yeah. So, work is equal force times what? Oh God, we got physics people in here. Displacement. And in calculus, that's basically work equals A to B of f of x dx. Now, there's several different types of work. We're going to be working with ropes and cables. That's basically how much work it takes to lift a cable up or a rope up. We're going to be working, of course, with our tank, our springs, using Hooke's law, and then we're going to be working with hands. Let's see if the eraser works in this one. So there, y'all. Y'all write that down. Tomorrow it won't work. Tanks. Right? Now, how many of y'all were in this Lord's class? One? One? Anybody else? Talk to us. So y'all, how much work did y'all do? How much? Like one or two problems, or did you? Were they ropes or were they tanks or what? A little bit of everything. How much time did y'all have to go over? Oh, she crammed. Yeah, I don't do that. I'd rather. I'm just telling you. I spend my time more on drilling the because I don't. Was it in the syllabus? I don't think so either. I'm not believing that. But that's just me. Um, and the best way to show these problems is to go to slide number one and show you how to do it. Um, yes, come on, y'all. So, most of your rope problem is going to be on building. I cannot get my mouse to work this fast. There you go. All right, so we got a 120-foot building, which is basically useless because the only reason you have a 120-foot building is you're going to have a 60-foot roof. And 120-foot building, you got to have a higher building than the roof. That's the only reason. So the 120-foot building really don't have anything to do with anything. Just telling you that the rope's not laying on the ground. You have a 60-foot 2 pounds per foot. Hey, how much work you pull the rope up? Steve, how much work you pull rope halfway up? Now draw a picture right quick. And when you draw a picture, leave some space out to the side so we can enlarge some stuff. Because we're going to blow the rope up into a bigger picture. So you don't want to put it down at the bottom of the page. You want to make sure you got at least half a page to draw a good picture. And then we're going to blow the rope up into sections. So, just a thought. Darn, I forgot to get my hot water. I suck. I don't drink coffee. This is tea. I can drink tea. What would you think my first... I haven't told too many people this. My first hot tea, where do you think I drank it? Anybody want to take a guess? Nope. One more guess. 6 miles. 6 miles from what? Actually, anybody in here know Ron Rash? Who is Ron Rash? He's my best friend. And in Salina, there's McClure Mountain and McClure Campground. And in not One Foot in Eden, he made the sheriff. The sheriff is like me, former Marine from Clemson, graduated at Clemson University, and Borderline Lounge is in One Foot in Eden. No, first one. Yeah, One Foot in Eden. Borderline Lounge is right below my house. And he said, I need to know the name of a redneck joint. You scared to go to? I said, the Borderline Lounge. He said, perfect. Anyway, I used to help him with, he used to come over to my office. We used to be side by side. He was my first English teacher in college. Remember, Miss Anthony, remind me why I'm telling you. Oh, the tea. Remind me about the tea. And Ron Rash, Ron is, he's normal, but he's got a little bit of eccentric. He's a little eccentric. A little bit. Not crazy, but just a little bit eccentric. And he'd sit in that office and the door would be closed, and all of a sudden he comes running over to my office. I need the name of this. I need the name of this. What would you do is you build a fence and there's in One Foot in Eden, there's all kind of references to barbed wire fences, and he would come and ask me questions about that. And then he would ask me questions about the Marine Corps, so he could put it in there. So in the first book, there's all kind of things that and in the second book, it's called Saints at the River. I'm a deputy, and he put me in there to beat up a hippie, and I beat up several hippies, and he took it out because he didn't want to offend anybody. So, but I'm still in there as Deputy Sheriff Hubert McClure, and I stand around and I make faces whenever the hippies come in. Anyway, but he got back to me. And in A World Made Straight, which is a movie, I'm Hubert Toomey. And Hubert Toomey's great-great-great-grandfather was Confederate soldier Hubert Shandon McClure. And then in Salina, I'm McClure Mountain. So that's my claim to fame. Yeah. 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 I've been to her house several times. He keeps his moonshine on top of the refrigerator. He's a good guy. If you ever read any of his books, they're real good. But that's the name of his book. So you have to read about it. Oh, in World Made Straight, Hubert Toomey is a former Marine, In the movie, they put him in the Army, but in the book, he's a former Marine. They wear the peace symbol. He did that just to aggravate me. So, anyway, I just filled all my notes. Um, yep, there's all my notes. Thank you very much, notebook. The tea was in the middle of the desert in Saudi Arabia. First time I had hot tea with honey. Anybody want to ask how? I was detached with a squad of Brits. You know what Brits are? What? Yeah, we call them Brits. That's what we call them over in Desert Storm. And I'm sitting there with my MRE because we didn't, Marines, all we got is MREs. I mean, we didn't have no fine cheeseburgers and French fries like some of the other branches of the service got. So we got MREs, and we'd have a cargo pocket with the MRE in each side, and in the Alice pack, we'd have 2 or 3 MREs, and then whenever the Humvee came around with the in certain fighting holes or whatever, we'd get another 5 or 6, and just you never know when you were going to get another MRE. These Brits, they had everything. I mean, they were in a fighting hole, but they had to stop to get their tea. I mean, it's religious. It's like a religion. And I'm sitting there eating my MRE, and they go, "Hey, chat," I don't know what they called me, but you want a spot of tea? And I'm like, tea? Yeah, I want some with some iced tea and some lemon in it. Oh, not that type of tea. Y'all messed that up. I was like, okay, whatever. And these guys are white as ghosts. I mean, they never get any sun in England, evidently. These guys, and they got burnt. They look like lobsters. And their head, and they shaved their head in the army. They shaved it, and their head was all peeling, and they looked like they had leprosy or anything. And then they said they pull out their little collapsible cups. It's like the silent drill thing. I mean, they took their little sterno, and they took their little teapot. And I don't know what it was, but they made tea. It had honey. Would you like honey or sugar? That was my first time I had hot tea. Anyway, how did I get on that? I don't know. But anyway. Huh? So, let's draw us a picture. And the reason I'm drawing a picture is just to kind of make sense. I would show you on a disc, but I don't have the software because, like Tony said, it's still with technology. Anyway, there's our rope. There's 60 foot. And we don't really care anything about that. Most of the time, when you're dealing with pulling up all the rope, all the way, usually your A to B is going to be the rope. Okay, remember that. When it's all the way. Now when it's halfway, it's a totally different animal. But we're going to blow this rope up, and we're going to make it look like this. And no matter what kind of work problem, I don't care where they're teaching it, I don't care who's teaching it, we're going to show it to you just like this. Because it's the best way to show you, and it's the best way to implement it. There's our 60-foot rope. And we're just going to take a section of this rope, like this. And the width of that rope, we're going to say is DX. Now you can put it right here if you want to, but I'm going to put it out here. DX. Alright? So, we're just going to call that DX. So that makes it right. This right here, now some books, this distance right here is going to be X of I. Now I don't put the X of I because that may get confusing for you. But it's going to be X. That's the displacement. Right? The displacement to move this spot all the way up here. Now, all that's going to be taken into effect when you put the 0 to 60 in. Alright? But this displacement is going to be a little bit different from this one. So, just take my word for it. When you put that X into the integration, it's going to take up further distance. Okay? Because X is always, X is 0, X is 1, X is 2, X is 3, so on. So it's going to take care of itself because you're going to split this integration. All right, so that's covered there. I don't know where it's set at, but John's talking now. So you take this right here and you move it. We know that work is equal to force times what? We know that, and we're going to do the displacement of the slice right here. And the work is going to be equal to something dx. And we've got 60 feet of rope and we've got it 2 pounds. Now, the 2 pounds, that's going to be your work. Your work. You're going to have 2 pounds and then you're going to have times what? dx. Because this right here is 2 pounds per what? Foot pounds. That's what? Work. Okay? When you have foot pounds, that's work. Alright? So you've got 2 pounds per 1 foot of rope. So it's 1 foot of rope, you got 2 pounds. What is the rope with 2 feet? Be 4 pounds. What if it was 3 foot wide? Then it would be 6 pounds. So is everybody with agreement that however long the width is, you multiply it by what? This, and you get, everybody agree with that? So width times width. Alright? So that's going to be 2 and then times dx. Is 0 to what? 2. That's your work. But your displacement, that's basically this here. It's going to be x. Okay? And it's going to be this one right over here. Displacement is just going to be x. So work times what? Displacement. And I'm going to just put displacement of the slice is equal to x. So I'm going to take this out, and that x is just going to fall right there because this is your work is equal to force length times width times displacement. So work is equal to 0 to 60 of 2 dx x. Alright, finish. Oh yeah, there's another one. There's 6 miles. That's what I thought of when you said 6 miles. He wrote a short story with me and him going up to New York selling pine trees for Christmas trees on a pulpwood truck. I got to tell you that story. He never did print it. I'm like, why don't you print it? It's hilarious. I got it at the house and I sent it around. I sent it around to some of my people that when I was in Oconee Hall, and they just laughed. They just thought it was hilarious, and he never did print it. He lives right above Bilo. Right above Bilo in Clemson, on the right. There's a subdivision up there on the right. If you're going towards Central, I can't remember. I know how to get there, but it's right after you pass Bilo and Gold's Gym. Right after you pass going to Central, it's about the first one on the right, the first subdivision on the right. It's right there before you get to Ingles. If Ingles is still there, Lord, I ain't been up there. Is Queen of Trail right before you get to Queen? Yeah. Right there. Well, it's right there. He's on a scale from 1 to 10. He's about a 5 or a 6. He's got 2 movies out, but he's not that type person. He's James Dickey type. Wrote The Lipper. You need to watch it. I've got it recorded. it every once in a while. I think it's a great movie. Yeah, yeah, I liked it. I just didn't get too much the way it ended. It didn't end like the book did. Did you read the book? Uh-huh. Yeah, and they did whatever they want to it. That's what he told me. So, because in World Made Straight, that wasn't written like the book either. They changed it to make it more. Yeah, yeah. Hubert Toomey was one of the main characters in the book, but in the movie he only saw him like 2 or 3 times. I mean, he was semi-main character, but he didn't have a peace symbol. He had a necklace on, but it wasn't a peace symbol. So he didn't have his USMC tattoo or anything like that. Well, he didn't. He wasn't. And then they put that he got discharged out of the army because he was crazy, and that's nothing like the book. You wouldn't know it by looking at him. He's real. Yeah, the real money. Yeah, real money is people's generous. Yeah, and he sells in Europe. Europe loves his books. People over there go crazy over his books. Yeah, because they're so deranged. Yeah. All right, so here we go. So this is pretty simple. 2x dx, that's going to be x squared. Come out to x squared. I keep reading my notes. Yeah, x squared. So that's x squared evaluated 0 and 60, which comes out to be 3,600. I'll do 0 for you. 0 is 3,600. 3,600 what? Please put foot pounds. Do I care? No. Who cares? You're on physics teacher. Yes, sir. Yeah, it is. Don't answer it. Oh, the integration. What do you mean? When you integrate, pull the 2 out, then what is x dx? When you integrate x dx, what happens? You get x squared over what? No, x squared over 2. And 2, the 2 is what? Got it? Now that was pretty stupid. I think you need to leave. Yes, sir. You gonna ask another stupid? I'll embarrass you too. That's W. W. W is just work. That's the formula for work. I don't really need this. It's just, this is how you find the work. Work is equal to force times distance. Here's your, this is your, this is your work right here. What is work? Length times width. Right here. Length times width. I'm sorry. Length times width. Okay. Now, since you don't have a length, your length is the work. The force is 2 pounds per foot. That's the force. Times the displacement. There's the force. There's the displacement. And I just put the x with the 2x right here. Now, after about the third, fourth one, you'll get it. Okay? Does that help? Is that like you covered it? Now do the other one. I'm gonna let you do it. I'll give you a hint. 2 parts. That's B. How much work? No, you can't just divide it by 2. Remember? Who asked that? Okay, it better not be one of my students. Why? One of my students. What did I tell you? Nothing's that what? Nothing's that easy. In calculus, nothing is that easy. So, how much work to pull up the rope? Two parts. I'll give you one more hint. Divide the rope into two parts. One. Divide the rope into two parts. I'm gonna go get me some hot water. This is not question time, okay? Actually, huh? Zeros at the top. Draw your picture. Zeros to 30. There you go. That's the first part. And then when you're pulling up that 30 foot, what's hanging below that? It's 30 to 60, and that's like a dead weight. Get it? Think of it like a hangman. If you're hanging something, the rope is doing the work, right? But what's on the end of that rope? Dead weight. Listen, if you can't do it, just quit. I don't know where to get it either. I don't know. Okay. 2x. What about the 2x squared over 2 is 2x? Am I crazy?
But then you cannot do the actual problem. So you need to recite it like that.
I don't know what you're talking about. I mean, I'm not trying to be difficult. Yeah, I am. Hold on a minute. 0, whatever. What is it? 2, 2x dx. Ain't that it? 2dx times x. 2 times 3 is the same as 3 times 2. Pull the 2 out. Okay, now the last time I checked, when you integrate x, Miss Blair, help me out. X squared over 2, right? Okay. I'm gonna finish this, and then y'all gonna say, Hubert, I'm sorry. Yeah, but you're gonna get x squared no matter what. That's right. You should get x squared. No, the constant rule says that you pull the 2 out. No. That I don't understand what that is. Look. All right, finish. Let me go get me some water, please. If you don't mind, can I get some water? Y'all finish the problem, and Miss Angie's gonna go back there. Now, are we okay with the x squared now? All right. Now this guy's a little bit different. Now, I'm exaggerating a little bit. It doesn't have stars sitting there or anything. But you're going to be pulling up half the row. Okay? So we're going to draw the row hook here. And we're going to mark this right here, 30. This is 0 row has been pulled up. Here, 30 feet has been pulled up. And here, 60 feet has been pulled up. So as you're pulling up the row, that's how it's going to look. All right? Here, we've got the same thing we had before. There's a section, the X at 2 foot per whatever. So the first part, the work of the top, is equal to 0 to 30 of same thing. This right here is X. So that'd be 2x dx. And that's the top. Now the bottom half is pretty much just what? It's just weight. Because once you get this thing right here up to here, you stop. So you're not going to be pulling this up with your hand. You're pulling it up to where this comes up to here. Now, you still have this guy right here. You still have him, dx, and at 2 blah 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 foot-pounds, 2 pounds per foot. You still have that, but your x is not going to be x. Your x is going to be 30. Why? Why is it not going to be x? Good try, but that's not it. It's real simple. Why is it not x? Why are you not multiplying by x? Why are you multiplying by 30 and not x? Why? You're getting there. It just what? It just moves. It just moves 30 feet. Yeah, just come on in. You want to come in at 11 next time? Oh, I'm sorry. You're in the Army, right? Y'all are used to sleeping late, aren't you? I can kid him. He can take it. All right. We're doing work. We started work, without them. So, in other words, let me ask you a question. If you pull this up X amount, right here, how far is this going to travel? How many? Okay, what about this spot right there? If you pull this up X, it's just 0 to 30 feet, but it's X because that's the displacement. That's what that's going to be. Pulled. Where's that dot going to move? It's going to move 30 feet. You see what I'm saying? The displacement is actually you working. All right? Don't tell a physicist that. All right? So he'll say, no, that's fine. But you actually pulling. This, you won't touch. It's just big weight. It's just like the bucket in your head. What's wrong with my bucket? Hey. If you draw, I tell you what, you come up here and draw with this thing. Everybody loves the truth.
Everybody loves the truth.
Who said that? Squibble. All right. So what is it? So integral work of the bottom is equal to the integral. We've got the 2. We still got the 2 and we still got the dx. So what else? Times what? It moves how many feet? 30 feet. Instead of the x for displacement, we put 30 because we don't actually pull it. It just moves. Now, where's our parameters going to be? 30 to 60. Now finish it. Did y'all do one of these in the 4th class? You remember? Did halfway? Okay. In my Calc 1 class, I spent a lot of time talking about converting the way you're thinking. Limits, you have to think totally differently. You have to think half of a half of a half of a step, if you ever reach the wall. And you have to actually go through and change your thinking. What about here? Do you have to change your thinking? Yes. Most people, unless you're a geek, don't sit around and go, let's say, watch is force times displacement. I mean, honestly, you don't think about stuff like that. And the thinking that I'm trying to get you to think is that 30 foot of rope there is a bucket. All it is a bucket. You don't even touch it. And if you don't touch it, the displacement is not going to be X pretty much. Because the work is actually being done on the rope with X. You know what I'm saying? Say again? Pretty much. Now, when I did it, I came up with X squared and 60X. So what y'all came up with? Unless you type it in Wolfram and get 15X squared. So I got from 0 to 30 of X squared and 60X from 30 to 60. Is that what y'all got? Goes from 30 to 60. Because this thing right here, you're right here. Where is it traveling? From 60 to what? 30. Don't try to start thinking. That's what you're trying to start doing. You're trying to say, well, just move 30 feet. Why couldn't you just get to 0 to 30? It doesn't work that way. Think of it as geographic rotation. It doesn't move from Greenville to Spartanburg. It moves from Greenville to Charlotte. Or Spartanburg to Charlotte. All right? Dead weight. You're not only pulling up the rope, but you're pulling up the weight. See, that's a lot of, you don't think like that. When I said pull up half the weight, most of you thought, well, just take the work and divide it by 2. It doesn't work that way. Nothing is that easy. I came up, check my math, 2,700 foot-pounds. But the reason they want you to see it like this is to make the relationship between half and dead weight. Because if I give you a question like with a bucket that weighs 20 pounds, see what I'm saying? Plug in 30 and 60. No, you always subtract. You always subtract when you do this right here. When you evaluate, you always subtract. This is always subtract. Think of it like this. If you go from Anderson to Spartanburg, let's say it's 60 miles. And from Greenville to Spartanburg is 30 miles. How far is it from Anderson to Greenville? You subtract. Okay? Always think about subtraction. I don't want to do that right now because that's joules and I don't want to move to joules yet. I'm trying to find one just like this one. I worked several of these. I'll do this chain problem. Now let's do the chain problem. I tried to do several, so y'all know what stuff's like. So, you got a 50-foot chain, and it weighs 150 pounds. Sometimes the question will just say that the rope or chain weighs 150 pounds. Doesn't give you anything else. You just got to part A and B. I think it does. Okay. Find the work. Nope, it's 150 pounds. Find the work to pull chain to the top of the building. Just, hanging off the side of the building on the top. Pull the chain to the top of the building. 5,000 feet. Doesn't matter. The building is always going to be longer than it doesn't have any effect. It's just long enough where the chain's hanging. It could be 51 feet. Huh? Yeah, it is. Pretty much. Say again? Yeah, always. Hmm? Well, you got a 50-foot chain and it weighs 150 pounds. I'm just showing you a different way the problem can be written. In other words, cannot be done is not the answer because nothing that simple. Or what some of y'all put, not enough information. much does the chain weigh per foot? 3 pounds per foot. So you're talking about a log chain. You're not, I'm sorry, a log chain. You're talking about one that's pretty thick. You're not talking about a dog chain. So is this the same thing as the rope? Yeah. And you're going from 0 to 50. You're pulling up the whole rope. You're moving X times. So it's going to be, what, 3X dx? Pretty much. So anti-derivative from 0 to 50 of 3X dx. That's going to give you 3x squared over 2, evaluated at 0 and 50. And that turns out to be 3 times 50 squared over 2, which is equal to 3 times 2,500. Y'all help me out here. So that's 1.5 times 2,500, so that'd be 2,500, so 3,700, 3,750. Foot-pounds. Now, where does this pay off? Well, mechanical engineers. What do you need to know how to compute? Well, if you have a winch or you design a winch, you got to know how much work is involved pulling a chain or cable or rope or whatever. Or, I don't know, you've seen these, have you ever been in Lakeside Metal over here? They have this big, it's 2 I-beams that go up and a beam that goes across, as big as a house, and it has basically a pulley in the middle, a mechanicalized pulley or whatever, I don't know what you call it, a motor. It would be a motor because it's electric. So a motor with a pulley on the end of it, and it lifts the steel. Okay, you've got to think about stuff like that. Nobody's ever going to walk up to you and ask you to pull a rope over a building. But this is the same thinking that goes into designing the horsepower of a motor that's pulling a pulley. Same stuff. But you got to crawl before you can what? Walk. Parents walk. Parents. They don't teach y'all anything. You got to crawl before you can poop? No, not poop. All right, here's another one. Got to discourage y'all some way. Let's see if I can discourage you with this one. $5 meter, there it is. You know something's different. 5 meter rope weighs 1 kilogram per meter. Now what's different? You physics people? Huh? The units are different. Now why is that different in physics? Metric system has to be what? It has to be changed to what? Acceleration being 9.8 multiply by 9.8. That's a refresher, not probably a blue. At the end, let's see, a 5 meter rope weighs 1 kilogram per meter, hanging a 70-kilogram outlaw. That's all I'm telling you. They want to know how much work is being done to hold that cowboy up. Well, the whole point is the work involved. No. Okay, I'm sorry. There's a 70-kilogram cement bucket on the end of this rope. Okay. Now remember, you got to use on the cowboy. You got to use the 9.8. 9.8 meters per what? Second square. Your physics teacher should have taught you that. You know, I really think before you design a bridge, you need to put the name of the person that designed the bridge. Yes, sir. Yes, sir. Huh? I'm sorry, you pull him up to the limb. You're pulling him up to the limb. I'm sorry. Yeah. You're pulling him up to the limb. You're getting the rope off the limb, so you got to pull him up. You're not going to just cut it and let him drop. Huh? Dang old mummy. Dang old chopper. Let him fall down. That's one of my favorite movies, The Mummy. When the mummy returns. I didn't like the last one. I didn't like that one. What? I recorded them too. I'm gonna drag my knuckles here. That woman on the first two, she was hot. I'm gonna drag my knuckles a little bit. She was hot. Yeah. You must not like bugs. I don't care about. Bugs don't bother me. Wasps bother me. I get away from them things. I got bitten too many times as a kid on the farm. Wasp nests are everywhere on the farm. Yeah. And no matter where you go, when you pick up something in the summertime, you're gonna get stung. Whether it's picking up a trailer or picking up a tire or you're gonna get stung. Just beef cattle. That's enough. Too many. Hmm? Good bit. Nah, about 100. Hmm? I don't know. I gotta add it all up. I paid $16,000 in taxes, which I'm thinking about selling some. I had to sell a whole cow. I had to sell a whole trailer load of cows just to pay taxes. No, not to pay the taxes. I didn't. Huh? Well, the farm and the land, the land has been in my family since the War Between the States. Okay, and the farm, we raised cows all our lives. So when my dad died, my mom and I just kept on raising them. Now, when my dad and I was working, we had close to 300. But we had to sell about 200 when. Oh yeah. Well, hopefully we'll get another president. Got a good president. We won't have to worry about starving to death. But anyway, um, when he got ill last year, we had to sell, get many of them pay bills. So we kind of rebuilding right now. I went and got my water, but I left my tea bag in the Alright. So with this one, we're talking about a rope and a body, or a bucket. You don't want to offend nobody. Just try to draw a perfect bucket here. I appreciate it. Thank you. Huh? Okay. Make Miss Anthony happy. Alright, 0 to 5. And of course, the 1 kilogram, that'd be 9.8, is basically your, yeah, 9.8 meters per second. I'm just going to put this out to the side out here. dx, so it's going to be 1 kilogram per meter, and times 9.8 meters. Is it per second squared? So you have to, because it's in what's that called? Thank you, metric system. Oh, is that point? You're not working with the metric system. And if you're working with the metric system, it's going to be different things. You don't work foot pounds. What is in metric system? Joules. But you're asking physics questions, okay? Don't ask physics questions. Well, you wouldn't have to do it, but you have to convert everything. Yeah, sometimes it can be easier to do that, but not much. But see, joules is per second. So we worked out here. Ask your physics teacher. Okay? He can explain, he or she can explain a whole lot better than I can. Alright, so when you get through, you're basically going to have, I'm going to just work this down. I used to have a teacher in my first year function, and we were in the doctor park. Actually had a little flat house right there with the kid, and we taught people like we did in years. And big grunt, little short man, about this tall, and he was very small, and he would grunt, grunt. Whenever he did this, whenever he put the 3 dots right here, he'd say, you know how to do that. That was, you know how to do that. You know how to do that. That's what you get. Y'all know that when y'all in function. I got from, make sure I got this all right. I think, yeah, I think I got this in 2 parts. I think I did that recently. The first part, from 0 to 5, and I've got down to 2 when I did this. 70 times 9.8, yeah, 2 parts, because it's dead weight, and that's dx, plus 0 to 5 of 9.8 times 1 times x from, well, you're moving it. You're moving it to, this is, this, but you have to have it from 0 to 5 because that's the only, um, it's a little bit different because with the rope we had that right there. So it's a little bit different because this right here is moving up here. So that's why we had to multiply it by the 30. Alright? This is not like that in the respect that this is just what? It's just right there. You don't have a link to it. You see what I'm saying? You see? That's why it's a little different. It's a little bit different, not the same. Okay? And then just work that out. I didn't work it out, so y'all can work it out if you want to. Hmm? Hmm? Because you pull this thing right here. What is this? What do we say that was? Displacement. Displacement. This little box right here, this little box right here, this little box right here. You got a bunch of little boxes. What is that? That displacement is right here, and displacement is what? F. Now, some books put it as y minus, or 5 minus y. And then they put it in terms of dy. Any way you do it, it's the same answer. Okay? But I like explaining it like this because people, they can grab on to X a whole lot easier than 5 minus y. Okay? So pull the 7 and the 9.8 out, and the 70 times 9.8, that's the bucket. The bucket cowboy bucket. Right there. And then this. Now, do y'all see this? There's no what in this one. Why? Because the bucket moves that distance. I think that distance looks right. But it doesn't move the same as the rope because it's not hanging down. It's right there at the end of the rope. That's why you must have that 30. Okay? Or a different. Okay? Well, let's go ahead and work it out. So 70 times 9.8, 70 times 9.8, x evaluated bracket the value of 0 and 5 plus 9.8. Now, I think I put that down in the next one here. So I have to do 9.8 bracket x squared over 2 evaluated at 0 and 5 close bracket. Alright, so 5, somebody take 5 times 70, that's 3,500, times 10 is 35,000. Okay, I'm sorry. 5 times 70 is 350. Then multiply by 10, that's 3,500. What did you get? 3430. Now, why would I use 3,500? No, not make it easier. What are y'all training to be? Most of you. Why? Over-engineering. Always over. Well, I'm say over complicated because we'll do that too much of that going wrong. But let's estimate up. Always estimate up. That's why you see me a lot of times do. I'm not an engineer. I'm not claiming to be an engineer, but I've always estimated up because my few semesters of being an engineer, that's what they always said do. And that's why I always take a 10. I always estimate up. And again, I'm not really divided by 2 is 12.5 times is 120.5, so that'd be 3150.5. Y'all check me. I got 3150.5. What'd y'all get? Well, it should be less. I've used the 10. I'm sorry. What'd y'all get? What's the answer? 30 what? 35. Yeah, 35. Sorry. 3550. What'd y'all get? Okay. I'll take either one of those answers. So you're still talking about a lot of what? A lot of work. How much is somebody, I don't know how many pounds are in a kilogram. How much? So we're talking 140 pound man or bucket. How much did the chain weigh? Now, this is not in foot pounds. This is in newtons. No, it's not newtons. Well, newtons per meter squared are, no, kilograms per meter per second squared. And that's a newton. I'm sorry, it's going to be in newtons. I thought it was in joules. For some reason, I thought it was joules. Kilograms per meter per second squared. That's the way the units come out, which would be a newton. Yes, sir. 9.8. Well, it's metric. You have to do that. Well, if you had a rope and you were pulling up the rope, you would multiply 1 times 9.8. I'll try to get a better explanation for you, but it's because of the units. Okay. Now, let's move on. Now that all my stuff is filled again, now all my notes are out of sequence. Really didn't want to move the tank this early. I'd like to find one more. We got hundreds of tank problems to do. Hold on just a minute and I'll find one. We already discussed that. We discussed that at the beginning of class. You wasn't here. Wonder why. I got Donald Trump and Ben Carson. I thought no, I was 90. I was 95. Well, I thought it was 90. I got it mixed up with. I don't know. It was 90 something. Oh. Well, I haven't either. So, and I signed up for it a month ago, or 2 weeks ago. I'm looking. Just hold on. All right, I'll just give you my ticket. Yeah. Huh? Is your family Trump supporters? Okay, I guess I'll have to start talking about. Yep, I'm gonna have to. I'm looking for one more. I could go to the book. Let me go to the book. Let me see if I can find one in the book. I can't really see up here. They give us so big of a desk up here. Is this 6.4? Here we go, 6.4. Oh, they don't even cover. They cover ropes. Well, there's hook claw. Yeah, yeah, yeah. They don't do too much. All right, let me find one. All right, there's one, number 13. Let's see if it's the same in your book. And then we'll do hook claw Thursday, and then move into tanks. This is so aggravating having to do this so slow. Yep. And then if we have any time left, we'll go over some today. Let's go with that one. Hold on a second, and I'll flip it out for you. It's number 13 in your book. All right. Up on that one. Just ignore the directions of Riemann thumb because you don't need to worry about that. Oh, it don't have any directions. That's good. So it looks like this one is going to be, of course you need to draw a picture of it, but W is equal to 0 to what? 50 of 1/2 x dx. Now why is that? Because this is your force, and this is your what? Displacement. So that's going to be, what is it? X squared over 2, which comes out to be x, no, it wouldn't be. 1/2, I'll write it out because it's easy to get tricked here. And that's x squared over 2, evaluated at 0 and 5. And that's going to be x squared over what? X squared over 4, evaluated at 0 and 5. And that's going to be 5 squared is 25 over 4. I'm sorry, what? Thank you. I just leave off at 0. Fine. That's 2,500 over 2, which is 1225. Somebody help me out. Yes, sir. The main thing is that you see that it's not that difficult. I'm sorry. I don't know where 1225 came from. 50 squared is 625. Oh, yeah. Oh, 2,500 over 4. What does that come out to? Oh, I was dividing it by 2 in my head. Sorry. 6 what? 625 foot-pounds. Okay. Now the second part. Well, you got to do half of it. Does it say half? Half the rope. So be from 0 to 25, the first part.
So the first part, you're not putting the foot count there at all. Or is that in the first?
Hmm?
And the last part. The first part.
I showed y'all right here. First part is 0 right here. There's 25 and 50. Remember, at this point up here, how much rope is being pulled up? Nothing. Then you pull up 25. 25 will be up here. So that's 0. This is 50. So 0 to 25 of 1/2 x dx plus the work from 25 to 50 of what? Well, the length, the height, yeah, 25 feet times what? 1/2 dx, right? 25 times 1/2 dx. No, 25 because how much does that box move when you pull up half the rope? 25 feet. Just like the bucket. The bucket could have moved 5 feet. But we put it in less than that one. Alright? So this turns out to be 1/4, or x squared over 4. Evaluated 0 and 25. 25 squared is 625. 625 divided by 4. 131. Somebody help me out. I don't know. What's 625 divided by 4? 156.25. 157. Or 156. Let's just say 156. Let's just say 156. 160. Alright. And 25, let's see, that's going to be 25 over 2, so that'd be 25 over 2x, right? So 25x over 2, so that'd be 25 times 50. Hold on a second, before you start reaching for a calculator. Silent drill team, I hear them already. Minus 25 times 25 over 2. And that's going to, that cancels that with 25. 25 times 25 is 625. Minus 25 times 25 is 625. Half of 625 is 312.5. And that leaves you with what? 312.5. I'm just asking. 312.5. Now, in this case, it came out to be half. But that's not always going to be the case. Alright, y'all had enough today. Unless y'all want to go into Hooke's Law. Huh? Oh, I'm sorry. We didn't add them together. I'm sorry. 312 plus 160 is what? 370. See, 472.5 or 473, whatever you want to say. You add these two, this one plus this one. I forgot to add it. So now that makes a difference. Okay, let me call the roll, and then I will put some, I'm just going to call them rope and cable problems, and I'll put some of those up tonight. Probably by the end of the hour. The ones that ask, when's it going to be due, that's usually